So this idea of doing more complex operations in memory requires us to have a basic understanding of references. References are not the same as values like primitives are. References are pointers. So let me show you what I mean. Let's say we wanted to create an int array. So this is an array of ints. I'll just call it my int array. And we're going to have to specify when we first create it the size of it. So this means there's 4 different positions, 4 different memory lockers, each of them being an int. We can actually put stuff in those lockers by describing which position. In this case, I'm saying the first position or the 0th position. And I'll say, let's make that equal to 2. Okay, so what has happened here is a couple things. One is that this particular piece of memory is being assigned 2. That's fine. This particular piece of memory is just a reference. It's not pointing to the actual value. It's pointing to an area in memory. And it knows that that area of memory will end after it gets to 4 positions. So let's go ahead and fill this array up with some more values. I'll put in maybe just even numbers for now. Just really simple and basic right now. And you'll notice that when I'm doing this, that the last position of the array is 1 less than the size. That's very important to know. A lot of programmers will come across these off by 1 errors because arrays tend to start with a number of 0 as opposed to 1. So this was fine because I created some data, but most of the time you might not actually need to have that data ready and available at that very moment. You might want to just create a reference for future use. So in this case, let me say my second array, and I'm going to do this. Now, what is this one's default value? I didn't actually allocate it like I did up here and create a place in memory for it. What it's actually equal to in the beginning is something called null. In fact, this statement right here is equivalent to saying this, if you don't define it right off the bat. What is null? Well, null is kind of like nothingness. It means this isn't pointing to anything. And you have to be very careful about dealing with things that are null. Oftentimes we create objects and create situations where we haven't quite set them to be what we're going to use them for. An example might be this, string my name. And later in my code I might actually say what that is. My name is Adam. Now I've gone from pointing to null to pointing to an actual string of data. Java objects do this all the time. Primitives will always have a value, but any type of reference type, which is pretty much everything else in Java, is always going to start at being pointing to nothing. It's up to you to actually point it to a useful part of memory. Let me show you something else that's interesting about this, so you can actually see how this assignment works. If I now say my second array is equal to my int array, then this particular variable is pointing to this data in memory. If, however, at this moment, I say my int array is equal to null, I'm not somehow deleting this memory at all. I'm just saying from this array, my int array, point, somewhere over here. Point into nothingness. Point to nullness. My second array is still pointing to this data right here. So managing these differences of pointing to actual memory or pointing to null is what's going to help you troubleshoot your code to make sure that things are working how you want.